So here we go. Today's notes are on course pack page 308. Page 308. Go ahead, pause the video, and make sure you have course pack page 308. This is the third day that we've been working on linear programming. Yes, we've been working on linear programming. We've done one day of just working with objective functions, the feasible region, and constraints. This is now the second day where you have to come up with the objective function. You have to come up with the constraints. You have to draw the picture yourself. And then from all of that, we can answer the question that came from the word problem. So let's do another one of these. So on page 308 in the course pack, the cost to run machine 1 for an hour is $2. During that hour, machine 1 produces 240 bolts and 100 nuts. The cost to run machine 2 for an hour is $2.40. During that hour, machine 2 produces 160 volts and 160 nuts. For the combined running time of no more than 30 hours, how long should each machine run to produce an order of at least 2,080 volts and 1,520 nuts at the minimum operating cost? So you read through this problem, and what you want to decide is, how are you optimizing? Am I maximizing or am I minimizing? For this particular problem, I want a minimum operating cost. So I want to run my machines, but I want to have it at a minimum operating cost. So my optimization is looking to minimize. Okay? What am I minimizing? I'm minimizing cost. How am I measuring that? I'm measuring that by the amount of time that I'm using on both machines. So I need to say that my variables, x, is the hours on machine 1, how long machine number 1 is working. My y, again, is hours on machine 2, how long machine 2 is working. So I have my variables, x and y. I want to minimize cost. So my cost equation, my objective function is going to be cost. And that's going to be limited by how much it costs. Machine 1 is $2 per hour. Machine 2 is $2.40 per hour. So I get my objective function to be c is equal to 2x plus 240y. That's my cost equation, my objective function. Now I need to look through here and decide, okay, what are my constraints? I have my objective function. What's my constraints? Remember, I always have the constraint, since I'm talking about real life things that happen in real life. My first two constraints, I kind of assume that x is greater than or equal to 0 and y is greater than or equal to 0. I'm limited to quadrant 1. Now, again, we don't always state this. It's something that we just need to know, that I have my constraints. I have to be in quadrant 1 for this to work. What other constraints do I have? What other things are limiting what I'm doing? Well, let's look back at my problem. Let me get this out of the way. Well, the first thing that's limiting that I can see from here is with a combined running time of no more than 30 hours. So that tells me that the hours on machine 1 and the hours on machine 2 has to be less than or equal to 30. So my first constraint is x plus y is less than or equal to 30. Because my time has to be limited, it's at least, make sure I'm reading this right. It said of no more than 30 hours, which means it can be 30 hours, but I can't go over. So it's x plus y is less than or equal to 30. What's my next constraint? The next constraint is the number of bolts and the number of nuts. How long should each machine run to produce an order of at least 2080 bolts. Let's look at my bolts. For my bolts, I have 2080. I want at least that, so I don't want less than or equal to. I actually want greater than or equal to 2080. I can have 2080 volts, but I want more than that if I can have more than that. So machine 1 in that first hour can produce 240 volts. Machine 2 in that first hour can produce 160 volts. So I'm going to have 240x plus, hold the phone. I'm going to change up my graph, so just give me a second. I'm going to go ahead and pause this. And so I went ahead and gave myself some more room so that I can write this out a little better. So again, I want to have at least 2080 volts, so I can have more than that. I want to go ahead and talk about machine 1 had 240 in 1 hour. Machine 2, we said, could have 160 in 1 hour. So that's the constraint for the bolts. I have the constraint for the time in green, and I have the constraint for the bolts in red. Let's talk about my third constraint. My third constraint is talking about, again, I already talked about machine 1 and 240 volts. I talked about machine 2 and the 160 volts. I talked about at least 2080 volts. My other constraint are the number of nuts. 100 nuts for machine 1 and 160 nuts for machine 2, and at least 1,520 nuts. So let's look and set up that function. That function I'm going to go ahead and do in black. And so again, I'm going to have 100 nuts for the first machine, 160 nuts for the second machine, and I want at least 1,520 nuts. So that's my third constraint in black. I'm going to go back up here and check some things real quick. I've talked about the $2. I've talked about the 240 volts, the 100 nuts. I've talked about $2.40. I've talked about 160 volts, 160 nuts. I talked about the combined time. I've talked about at least 2080, at least 1,520, and I know I'm looking for a minimum. So I've used all the information that's given to me. I'm saying 3 constraints, but don't forget I have these 2, so technically 5 constraints that I want to go ahead and graph so I can see what my idea looks like. Remember, this is my x-axis, and this over here is my y-axis. I'm going to go ahead and start both of my x and y at 0, and I'm going to count by 2s. On my x, I'm going to call this hours. Excuse me, that's not an hour. Hours on machine number 1. And over here, this is hours on machine number 2, and that's an I. Okay, I'm going to scoot this over just a little bit. Shrink that down a little bit. Okay. Make sure I have enough room. Okay. I did say that I was counting by 2s, so I want to go ahead and graph my constraints. Let's look at my constraints. My first constraint that we're doing in green, we said was x plus y is less than or equal to 30. Well, let's find my x and y intercepts. Intercepts seem to be the easiest way to do these problems. My x-intercept, if I plug in 0 for y, is 30. My y-intercept, if I plug 0 in for x, is 30. So I end up with x-intercept of 30, y-intercept of 30. So if I'm counting by 2s, this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. This is the point 30, 0. And if I go up, I already know that there's 16. So this up here is my other constraint. This is the point 0, 30. So then I can draw that line. And I'm going to use my green. Ooh, that's not a green line. Use my green line. There's my first constraint. Okay. My second constraint, let's go ahead and look at that. Move. Oh. I'll fix. Okay, so I just rearranged some things. My second constraint is the equation 240x plus 160y is greater than or equal to 2080. So again, I want to go ahead and find my x and y intercepts because that is the easiest way to graph these. If I plug 0 in for y, it's 2080 divided by 240, and that's going to be 8.7. If I plug in 0 for x, that's 2080 divided by 160, and that's 13. So I can go ahead and plot these 2 points in red, 8.7 and 0, 2, 4, 6, 8.7 is almost 9. And then 13, 2, 4, 6, 8, 10, 12, right in the middle. I want to draw this line, so I'm going to use a red line like that. Now I have my third constraint. My third constraint I did in black. I'm going to go ahead and show this work down here. And that third constraint, I'll show it over here. We have 100x plus 160y is greater than or equal to 1,520, running out of room. And again, I'm going to plug in find my x and y intercepts, plug in 0 for y. That's 1,520 divided by 100, so that's going to be 15.2. And then plug in 0 for x, it's 160y is greater than or equal to 1,520, so 1,520 divided by 160, and I'm going to get 9.5. And again, I can plot those 2 points, 15.2 and 0. So this was 2, 4, 6, 8, 10, 12, 14. 15 is right in the middle. 15.2 is a little bit to the right of that. 9.5, 2, 4, 6, 8, 10. So 9.5 is right there in the middle. Draw that with a black line. So I drew all my lines by using intercepts. Let's look at what I'm doing with this. In green, I want less than or equal to the green line, so I want less than it. In red, I want greater than or equal to, so I want greater than or equal to the red line. And in black, I want greater than or equal to. So in black, I want greater than or equal to the black line. So the region that I'm looking at is this bounded region. I'm going to do this in blue. That, again, it's bounded by the y-axis because I can't have any negative hours on a machine, but it's also bounded by the green, bounded by the x-axis, and the black lines here. So this here is my feasible region that I'm talking about, that I will want to use. So if I transfer all my points to the graph, I realize that up here I have 0, 30. I have 30, 0 down here. In red, I have the point over here of, that's not red, 0, 13, and this point down here of 8.70. And then in black, I have this point over here of 0, 9.5, and this point over here of 15.20. Another constraint point that I have is the point 0, 0, and I have one other point that I need. It's the intersection of the black and the red lines, the intersection of the constraints of the nuts, of the bolts and the nuts. So I need to find the intersection of these two lines. Well, I need to find that intersection, so I'm going to go ahead and do elimination. Since I have 160y and 160y, I'm going to multiply the bottom equation by -1 and add 240x minus 100x is 140x. 160y minus 160y is 0. 2080 minus 1520 is 560. So divide both sides by 140, and I get x to be 4. So I know that x is 4, and now I need to find y. So I'm going to plug this into the bottom equation here. So 100 times 4 plus 160y is equal to 1,520. So this is 400 plus 160y is equal to 1,520. Subtract the 400 from both sides. 160y is equal to 1,120. Divide both sides by 160, and I get y to be 7. So this tells me that this intersection point that I marked here in blue is the point for 7. Machine 1 working for 4 hours, machine 2 working for 7 hours. That is going to go ahead and give me, well, less than the 30 hours, and this is going to be a possible minimum. Again, I want to try all of my critical points. So let's look at my critical points. So I know that my objective function was cost is equal to 2 times the number of hours for machine 1 plus $2.40 times the number of hours for machine 2. I have several critical points I need to check. I have my first critical point is the point 0.13. I have the critical point 0.30. I have the critical point 30, 0. I have the critical point of 15.20. I have the critical point of 4.7. Now wait, you're going to say, hold on, there's 3 other critical points that I can look at. What about 0, 9.5, 8.70, and the point 0, 0? All of these points are actually outside of my feasible region, so I actually don't have to check them because it's not part of what I want. I just have to check the points that are in my feasible region. So I'm checking the point 0.30, I'm checking the point 4.7, 0.13, 15.20, and 30.0. Those are my critical points that are in my feasible region, so those are the ones I need to check. The ones outside, I don't need to check. So let's go ahead and check this. My first one, 0.13, let's go ahead and do this. That's going to give me 2 times 0 plus 240 times 13. And that is going to give me 31.2 as my cost. $31.20. 0.30 to 0 plus 240 times 30. That's going to give me a cost of $72. 30.0 is 2 times 30 plus 240 times 0, and that gives me a cost of $60. 15.2 and 0 is 2 times 15.2 plus 240 times 0, that's going to give me a cost of $30.40. And my last critical point of 2 times 4 plus 2.40 times 7 gives me a cost of $24.80. These are all my critical points. I definitely can see that I have my maximum is 72, but my minimum is 24.8, and I'm looking for a minimum. Minimum, not minimum. Let's get that right. Minimum. So what I'm looking for here is to minimize my cost. So $24.80 is my minimum. So for my conclusion, I'm going to say to obtain a minimum cost of $24.80. Machine number 1 should operate for 4 hours, and machine number 2 should operate for 7 hours. That's going to get my job done. That's going to meet all my constraints, and that is my answer. Hopefully that is helpful. That makes sense. You can see how this works. Yes, these are long problems. Yes, they are time consuming, but yes, you are capable of doing these types of problems. Have a good day.